Okay, so now let's take a look at part 2. Okay, this is a little bit different. Instead of being given the symbols and trying to figure out the number the symbols represent, now you're given the number and you have to produce the symbols. So let me scroll down here so you can see the type of problem I'm talking about. Move these down a little bit too, I think. Okay. So we're going to first use number 2, part A. And so on this one, we want to figure out the Egyptian numeral for 7. Okay, so you look over here and you try to use these pictures to figure out what the Egyptian numeral for 7 would be. And it's relatively simple because, you can't use a heel bone, you have to use those vertical staffs. So you just have 7 of these vertical staffs. So it's like 1, 1, 1, 1, 1, 1, 1, 7 times. So 1, 2, 3, 4, 5, 6, 7 vertical staffs. So you can see sort of one of the inefficiencies in the Egyptian numeral system. Like if you want to represent 9 things, you have to draw 9 vertical staffs. For the Babylonian numeral system, this should be relatively easy. We look down here, the Babylonian numeral system, and 7 is represented by, again, 7 sort of like vertical staffs. And so we draw them like this. So this would be 1, 2, 3. And then it looks like you have 3 more right underneath it. So 1, 2, 3. And then one sort of fat one right there. All right, so that looks like 7 in the Egyptian numeral system. Over here with the Greek numeral system, we can pull it up, and we just look for the number 7. It looks like it's like zeta, right? Not a simple Greek letter to draw, but we can approximate it close enough. So zeta looks something like that, let's say. Right, so there's my zeta. And finally, Roman numerals, you probably don't even need to look at the system over here that's given, because it's just V, I, I. Okay, so 7, pretty simple. Let's look over at 78. Okay, so for 78, we come back here and we take a look at, for the Egyptian numeral system, we want to do 78. So, we can do heel bones, and we can do 7 heel bones. So let's do 7 of those. So here's 7 heel bones. 1, 2, 3, 4, 5, 6, 7 heel bones. And then we have to do 8 vertical staffs. 1, 2, 3, 4, 5, 6, 7, 8. But again, the point of this particular problem is to sort of demonstrate the sort of inefficiencies endemic to the Egyptian numeral system. The Babylonian numeral system now, remember, it's base 60. So the idea is you have to actually write this in terms of 60s. So what I would probably start off with is, you have a 1 spot and you have a 60 spot. Right. You don't need a 60 squared spot, because 60 squared, if you check it on your calculator, is 3,600, and that's way too big. And so you kind of think about this as saying, okay, well, how many 60s do you have in 78? Well, I just have 1. And then I have 18 little units left over, and so I can put that right here, 18. And so that's equal to, in terms of Babylonian numerals, I guess we should pull these back up. So we look at the Babylonian numerals. Okay, so what we can do is we can write the 1 as a simple vertical staff. And then we can write the 18. When we come over here and look at 18, it's a little wedge. Look at a nice big space. So we have a wedge like this. And then we have probably 8, right? 8 vertical staffs. So 1, 2, 3, 4, 5, 6, 7, 8. Right? And so this is how we would represent the number 78 in the Babylonian numeral system. All right, so for now the Greek numeral system, pull up the Greek numeral system right here. what we would do is we want to represent 78, so we need, a 70 and an 8. So you look over here, a 70 is this omicron, and so that's like a letter O. And so we write down sort of like the letter O. That represents 70 things. And then we have an 8, and so an 8 is its eta. It's sort of like an N. And so we write eta next to it. Right, so that's 78 in the Greek numeral system. And finally, for the Roman numeral system, well, we can just do a 50, right? So we write an L. And then we have, 20 will get us to 70, so we can write XX. And that's 20. And then we need 8, so VIII. And so there it is in the Roman numeral system.